welcome to circuit number 14 of the SparkFun Inventors Kit Guide. So, this time we are delving into the world of integrated circuits. So, we need this guy, the integrated circuit. It's also called a serial to parallel converter, and what this allows us to do is we can take 3 outputs from our breadboard and actually expand it to 8 outputs to be able to control these lights here. So we're going to need 8 lights, obviously, 8 330 ohm resistors for them, a whole bunch of wires, I believe we got around 19, and then of course the key to the whole thing, the secret to the sauce, is this transistor. So it comes in this little foam thing here, and as you can see, it's got these little pins. Alright, so you need to make sure that these are bent at a nice 90-degree angle, so you're going to need to squeeze them in. And if you look on this side, you can see there's a little divot right in the front here. That shows where pin 1 is, so you can make sure that that's the first one. Okay, so you've got that little guy ready to go. I'm gonna hook up this circuit and we'll take a look at it. Okay, so we've got the whole circuit built up. There's lots of wires and little lights and resistors, so make sure you got them all in the right spot. Of course, the key here is the integrated circuit. So this integrated circuit is just like the ones you see here on the breadboard, just a simpler version, obviously. But yeah, so you know, integrated circuits are used in all sorts of places. So let's plug this guy in and let's load up our little program. Here we are with circuit 14 loaded up in our IDE. So the beginning comments here explain a bunch about integrated circuits. I personally don't know that much, but feel free to look up on your own. You can read the comments here. There's a little data sheet, PDF. Yeah, but the basic idea I've already explained is that you can expand the amount of control ports, basically, that you can use with your Arduino. So first of all, we're going to set the pins that we're going to use the integrated circuit control with. Excuse me. And just set those up in our setup. Now for our main loop here, you can see some of these functions might look a little familiar. That's because we used them in circuit number 4 when we had multiple LEDs. So they follow the same pattern, one after another, one at a time: ping pong, random LED, and marquee. Now there's a new one here at the bottom called binary count. So we have 8 lights, and if we use each one of those as a binary digit, we can represent the numbers from 0 to 255 in binary. So basically binary count will just take a number and represent its binary value using the LEDs. So pretty simple. Now these guys here, these functions from the other program that we had, they use the digital write function. So basically we just set the high output to it to turn it on and low to turn it off, and that was with the digital write function. But we can't really use that now with our integrated circuit. What the integrated circuit does is it uses this command called shift right, which is this function right below. So what the shift right one does is it basically takes these 2 values as input, so the pin you want to set it and the state that you want to set it to. And it basically does that by taking a data value, a byte data value that we have set up, and sets it here and writes it out to the circuit, and then this kind of latches it on. I don't know what exactly that means, but basically you need to do it and it'll allow the light to turn on or off or whatever. And then these programs, they are the same, so I won't really go through them anymore. I'll look at this binary count one with you here though. So we've got a delay time that's 1 millisecond, or sorry, 1000 milliseconds, which is 1 second. And then we basically call our shift out and set it to our data value, and then we write it out, and voila, then we increment the data value by 1. So we're going to start from 0, go all the way to 255. Now you might be asking what happens when we get to 256. Well, we only have 8 8 LEDs to represent our number, so our max is 255. So basically if you get to 256, it's just like rolling around to 0, so we can just keep increasing it to whatever. And then we delay, and that's it. So I'm going to verify this and upload, and we'll see how it runs on the actual Arduino board. Okay, so first up we're going to load up the one after another pattern. We'll do that real quick here. And as you can see, same pattern, just like circuit number 4. I'll do the next one. Okay, this one's one at a time. There you go, pretty easy. The next one is ping pong. Back and forth, just like that. Okay, and we'll do the random LEDs. There we go, all random. Cool. And then the marquee is next. There we go. Lighten up all nice. So that's all the ones that are the same as circuit 4. So let's try the binary count, which is new to this one. Okay, so our bit patterns, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. You get the idea. Okay, so yeah, it's just counting out the bits in number form there, I guess, or the other way around, counting out the numbers in bit form. So that's about it. Pretty easy circuit, just takes a little while to build, but it's not too difficult to understand and get it all together. So yeah, you can now use only 3 little outputs on the red board to control basically any number of outputs that you want. So that's pretty handy. Alright, so see you next time with circuit number 15.